Bismillah ar-Rahman ar-Rahim. This is teacher Eman AlKhalidi explaining from Algebra, chapter 3, Probability, section 3-4, series of frequencies and binomial rule. Now let's see what is that binomial rule. We call it binomial because it is a probability between two things like success and fail. So we are going to find a probability of success and fail. Like, for example, when you are doing an experiment of toasting a coin. So you will get head or tail. So if you get a toast it and you will get head, for example, you decide to make it success, and the opposite will be fail when you are getting the other choice, which is tail. So this is the way to deal with binomial probability. For example, if you want to get any two things or an experiment, including two opposite things. Now the rule is saying a probability of x equals to n combination x multiplied by p to the power of x times q to the power of n minus x. That all equals to n combination x multiplied by p to the power of x times 1 minus p to the power of n minus x. You can see that this q is a complement of b. Because of that, we wrote it as 1 minus p to the power of n minus x. And we need to know what does this x and npq means. So we are going to discuss each. N means the number of trials. Like, for example, when we are doing an experiment of toasting a coin, you can toast it 10 times. That means the number of toasting it is 10, which is N, number of trials. And X means the number of success time. For example, when you are toasting it, you want to find the probability of getting head. So when you are getting head, you are getting success time. And if you don't get head, you get fail time. So the number of success time, we're going to call it X. And what do I mean by P? It is the probability of success in each trial. That means if you want to get head, the probability of getting head is half because it is one of two outcomes. And the probability of opposite of success is getting fail or of fail on each trial. And that can be calculated by the following rule, which can be the complement of P. Q equals 1 minus P. Why we are writing 1? Because the highest value for the probability is the probability of the sure event, which is the sample space, which is the certain event, which can be 1. So because of that, we're going to say 1 minus this P. Now let's have some conditions about using this probability. To find the probability of the events, the following conditions must be satisfied. Each trial completely independent from the other. Independence means that each event can't affect the other or do not depend or doesn't depend on the other. Like, for example, when we are doing an experiment of toasting a coin and we're going to toast it 10 times, the outcomes we are going to get them from the fourth trial doesn't depend on the next trial or doesn't depend on the third trial. And none of them depend on before. So each of them is independent. Now, number two, the probability of success remains constant in all trials. That means if I want to get head in each, so the probability of getting head is always half in tossing a coin experiment. So it can stays constant. In three, each trial is either success or fail. So when you are doing a trial, you might get head to be success or tail to be fail. Now let's have an experiment to understand the following. Example number 1. He said a fair coin is toasted 6 times. When he said fair, this means the coin has equal probabilities and equal appearance for head and tail. So each will have half and half in the probabilities. And toasting it 6 times, that means the number of trials for this experiment is 6, which is going to be the value of n. Now he's going to ask about what is the probability to get 2 heads, B, 4 heads at least, C, no head, D, 1 head at least. Before you're going to solve this, you need to know how much is N and how much is B and Q. N is 6 from here. He said toasted 6 times. And P and Q will be half because the probability of getting head, which is the success time, is half. And the Q, which is the fail probability, which is getting tail, is half. And here they are equal actually in toasting a coin. Now we need to solve first. A, 2 heads, getting 2 heads. That means x is equal to 2. According to the rule, we are going to write in combination x, which is 6 from here, combination 2 from here, multiplied by p, which is to the power of x, half to the power of 2, this is x, times also q to the power of the difference between them, which is half to the power of 6 minus 4, which can be written as 4. Now, how to calculate 6 combination 2? It is two consecutive numbers starting by 6, which are 6 times 5 divided by 2 consecutive numbers, which are 2 times 1. After canceling 2 with 6, you will get a 3 multiplied by 5, you will get 15 times 1 over 2 to the power of 6 by adding the powers. And then if you multiply 1 6 times, you will get 1. And the 2 6 times, you will get 64. Then you will multiply 15 by this one to get 15 over 64. Remember that the probability should be smaller than 1 and bigger than 0. And B is asking to get a probability of 4 heads at least. When he said at least, you're going to say that X and bigger because it might be 4 or 5 or 6, and you're going to stop at 6 because no more. So you're going to try it 3 times. And or probability can be calculated numerically by writing the symbol plus, or you can add them. So after that, you can apply the rule, which is in combination, the first x is 4. Then you're going to write 5 instead of x, or it might be 6 instead of x, because at least 4. So let's apply the rule 6 combination 4 times half to the power of 4 times half to the power of the difference between them, which is 2. A plus 6 combination 5 and half to the power of 5 and times half to the power of 1. A plus 6 combination 6 times half to the power of 6. And you might write 1 over 2 to the power of 0, which is the difference between 6 and 6, and which can be 1. No need to write it. Now let's evaluate each. This 6 combination 4, we can simplify it by using the simplification property of combination by subtracting 6 with 4 to get 6 combination 2. Multiply by, if you have the same base, you can add powers to get half to the power of 6 plus, here 6 combination 5. Again, you can use the simplification of a property or a property of simplification, which is 6 combination 1 by subtracting 6 with 5 times 1 over 2 to the power of 5 and 1 to the power over 2 to the power of 1. By adding powers, you will get 6. This all plus. Here, 6 combination 6 is 1. You can ignore it. And here, 1 over 2 to the power of 6, you can write it alone. Now you can see that 1 over 2 to the power of 6 can be taken as a common factor and see what is left. Bracket 6 combination 2 plus 6 combination 1, a plus 1 because nothing is written here. Now evaluate each. You can see that 1, if you multiply it 6 times, you will get 1. 2, if you multiply it 6 times, you will get 64. And the 6 combination 2, you can write 6 times 5, divide by 2 times 1. By canceling 2 with 6, you will get 3. 3 by 5 is 15. A plus this 6, which is a 21 plus this 1, it's a 22 over the 64, and you can cancel up and down by 2 to get 11 over 32. And remember, you should get in the probabilities, always the result is less than 1, bigger than 0. One head at least. That means, no, sorry, in C, we have no head. No head, that means x is equals to 0. And if head doesn't appear, the tail will appear in the whole time. So the six times that we're going to draw it, always we will get that failure result. Because of that, we can depend on that rule and make it rule always. Probability of x equals 0 is equals to q to the power of n. It's a rule now. By writing the rule, you can see that 6 combination 0 times half to the power of 0 will be cancelled and there will be 1 over 2 to the power of 6, and that means it is only the q, which is the probability of fail, to the power of an n. And you can write it correctly 1 over 2 without writing that all. To the power of 6, which is 1 over 64. Remember, the numerator is smaller than the denominator, which is smaller than 1. Now, in the last example, one head at least. We can say that one head at least means it is from 1 and bigger. So we can write it as x bigger than or equals to 1, which is 1 or 2, 3, 4, 5, or 6. And this is hard to write in the exam. It takes a long time. So we can depend on that following rule, which is 1 minus q to the power of an n, which is Lx when it can be equal to 0. When will the fail when the fail probability gonna appear, which is gonna be 1, يعني the whole, that means the whole certain probability minus the one that we don't need it, which is the appearance of tail. So if we're gonna cancel the appearance of tail, we will get head always. And this is what we need, at least one head. So that will be written as 1 minus 1 over 64, which is after equaling the denominator, 64 times 1 is 64 minus 1 is 63 over 64. Remember, the numerator should be smaller than the denominator. And remember, if you add this one and this one, you will get the certain event, which is 64 over 64, which is 1 to be sure that your work is right. Now let's have another example, which is example 2. More ideas with more examples. Example number 2 is saying we're going to have a hunter shots 3 bullets to a target. That means the number of trials, which is n, should be 3 because he's going to shot it 3 times. Now, if the probability of hitting the target is 0.6, this we are going to get it to call it P, which is the probability of success. And we should mention how much is Q, which is the complement of success, which is the probability of fail, by using the rule of 1 minus P, which is 1 minus 0.6. That will give Q equals to 0.4. Now we need to find the probability of hitting the target 3 times, hitting the target only 1 time, missing the target once, and hitting the target at least 2 times. Now, before you're going to solve this, you are going to think about how to write N and P and Q. You can write them first, like that. N is equal to 3, which is the number of tries, and we can find it from here because he's gonna shot him 3 times after each other. Let the probability of success is hitting the target, so the probability of success is 0.6, and the probability of not hitting it is 1 minus b is 1 minus 0.6, which is 0.4. In A, the probability of hitting the target 3 times will make x equals to 3. And we're going to deal with the rule, probability of x equals to 3 equals to a 3 combination of 3 multiplied by p, which is 0.6 to the power of 3 times 0.4 to the power of the difference between 3 and 3, which is 0. This and this going to be cancelled to be 1, and there is left 0.6 to the power of 3. You should multiply it 3 times to get 0.216. Remember, your answer should be smaller than 1, bigger than 0. In B, the probability of hitting the target once. That will make x equals to 1. And you will deal with the rule, which is the probability of x equals 1 equals to 3 combination 1, 0.6 to the power of 1. No need to write this one, and 0.4 to the power of 2, which is a difference between the 3 and the 1. Now evaluate each. The first is the 3 times 0.6 times 0.16, which is 4 times 4, and after multiply them you will get 288. Don't forget to write it after three decimal places, because you have here 1, 2, 3 decimal places. See the probability of missing the target once. That means we are going to hit it 2 times. So that will make it x equals 2, and probability of x equals 2 after using the binomial rule, you will get a 3 combination 2 of 0.6 to the power of 2, and 0.4 to the power of the difference between them, which is 1. A 3 combination 2, that's mean we're going to write a 3 times 2 over 2 times 1 times 6 times 6 is 0.36 times 0.4. Now you can multiply this all or cancel 2 with 2, and then you will get the answer is 0.432. Now, in the last, we need to find the probability of hitting the target at least twice. That's mean 2 and 3, because finally we have a 3 times. In that case, you are going to do it 2 or a 3, or means a plus between them. So you're going to use the rule 2 times. Here, 3 combination 2, then 0.6 to the power of 2, which is the value of n of x, and then 0.4 to the power of 1, which is the difference between 3 and 2. A plus, you will get a 3 combination 3, 0.6 to the power of 3, and then evaluate each. You will get 0.432 plus 0.216. Add them, you will get 0.648. Remember, your answer should be smaller than 1, bigger than 0. Another example and more ideas with more examples. We will have example number 3, which said a die is rolled 7 times. So when you are repeating the experiment many times, that means you are dealing with these sequences and series of sequences trials, which can give you the number of n, which is 7. N means the number of these trials, sequence trials. So we can say that n is now known, which is 7. And we're going to consider that the success is getting the number 5 or 6. So in that case, the probability of getting 5 or 6 is 2 over 6, because they are two numbers from, or two outcomes from 6. Now we need to find the probability of the following events. In number 1, getting this 5 or 6 exactly 3 times. No, getting 4, 5, or 6. And in number 3, we are going to have getting 5 or 6 at least once. Come on, let us see how to find NPQ first. N, we said it is 7. But remember, to find P and Q, you need to remember how much is the sample space. The sample space including 6 results, which are, or 6 outcomes from throwing a dice. So you will get 1, 2, 3, 4, 5, 6. And that can help you to find P or Q. P is getting 2 numbers or 2 outcomes from these that will make it 2 out of 6, which can be equals to, after canceling, 1 over 3. Now this is P. To get a Q, you have to do the complement of that by using the rule 1 minus P, which is 1 minus 1 over 3, which is 2 over 3, by equaling the numerator. In number 1, he is asking about the probability of getting the two numbers 5 or 6. 3 times. That means x should be equals to 3, and you can use the rule exactly like that. 7 combination of 3. 1 over 3, which 4p to the power of 3, which is the value of x. And the probability of fail is 2 over 3 to the power of the difference between 7 and 3, which is 4. After you can evaluate these fractions, you will get 560 divided by 2187. Remember that the numerator should be smaller than that denominator. Into the probability of not getting the two numbers 5 or 6. That means it is a q to the power of an n because x is equal to 0. X is probability of x equal to 0. We have a deal. We can make it as probability of x equal to 0 equals to a q to the power of an n. It's a rule now, which is 2 to the power of 3 to the power of 7 can be calculated in that way, 128 over 2187. Remember, the probability should be smaller than 1. That means the numerator should be smaller than the denominator. And in number 3, the probability of getting the two numbers 5 or 6 at least once. At least we have also a rule. We said it can be written as 1 minus q to the power of n. It's now a rule. Always we have to use it when we say at least once. We calculate it here, so subtract it from 1 to get the following. You will get finally, after equaling the denominator, the following. So you will get probability of an x, which is 1 minus x, so q to the power of an n is 1 minus that result. After equaling the denominator, you will get 2059 over 2187. Remember that the numerator is bigger than the denominator to make it smaller than 1. Now more examples and more ideas. This is example number 4. Let the probability of delivering a boy is equal to half. And the probability of the children's sex is dependent from one child to another. If a family has 4 children, what is the probability that all of them are males? At least one of them is a male. The number of males is equal to the number of female. We need to know how much is NPQ. We can see that they are going to get finally 4 children. The family will get or has 4 children. So in that case, this is the number of N. And P should be boy or girl. So that means the probability of success is half and the probability of fail is half again, which are equals. In 1, we say that assume that A is the event that all children are males, because he said that all of them are males. So the 4 should be males. That will make x equals 4. And you can use the rule. Probability of that x equals 4 will make it 4 combination 4 times 1 over 2 to the power of 4 times 1 over 2 to the power of 0. And that means you're going to multiply 1 4 times to get 1 and 2 4 times to get 16. Be sure that the probability is less than 1. And 2, assume that B is an event that at least one of them is male. And since the probability of getting female for the children, for all children, is q to the power of an n. This is how to say that we are going to get at least one of them is male, so you have to make it 1 minus q to the power of n. Before that, you need to find q to the power of n, which is how to get female, which is female probability 1 over 2 to the power of 4, which is 1 over 6. Now you need to subtract it from 1 to know how much at least you will get once. 1 minus the q to the power of n is 1 minus 1 over 16, which is after equaling the denominator 15 over 16. In 3, assume that C is an event that the number of males is equal to the number of females. That means X will be 2. And you are going to deal with the rule by the following way. For combination 2 times half to the power of 2 times half to the power of 2. Look, males and females are equal in each family. So you're going to do it in that way. 4 times 3 over 2 times 1 times 1 over 2 to the power of 4 after adding the powers if you have the same basis. And after evaluating or canceling these, you will get a 3 over 8. Remember to make or to be sure that your answer should be smaller than 1. The next example, which is 5, we will get how many times should a coin be tossed so that the probability of getting ahead at least once greater than zero point 0.9. To try to translate this question, read it again and try to know how much is N, how much is P, how much is Q. Remember, your experiment is toasting a cone. Toasting a cone. And in cone, you have only two outcomes, which are head or tail. So getting ahead means P will be half. A Q will be half for getting tail. They are equal. And when he said probability of getting ahead at least once, we have a rule for that, which is 1 minus probability of N, probability of Q. So we have for that probability of getting ahead at least once a rule, which is 1 minus Q to the power of N. When he said greater than, we're going to make it bigger than zero point 0.9. But how much is N? We are asking about that. How many times? How many times should a cone be toasted? So that's mean we don't know how much is N. We need to find it. So the question here is coming in an opposite way. Always in before, he is giving you N and asking for the probability. Now he is not giving you N and asking you to find it. So let's make the relation between them. Easily, we can say that the rule for getting ahead at least once is 1 minus q to the power of n. We have to search for the smallest number of this n, where this q to the power of n should be smaller than zero point 0.1. How we got this? Because we said that this 1 minus q to the power of n is bigger than zero point 0.9. If you, after you are going to try to deal with the inequality and make it oppositely, you think about q to the power of n is smaller than zero point 0.1. So let's deal with that. Now we know that the probability of getting head and probability of getting tail are equal in this experiment of toasting a coin, which is half, so that will make P and Q is half to deal with the probability. We find that Q to the power of n by putting n equals to 1, 2, 3 till until we get Q to the power of n smaller to zero point 0.1. So that's mean we are going to replace. Let's replace it q to the power of 1. Dealing with that rule. Q to the power of 1 will give me half from here to the power of 1, which is not less than zero point 0.1. So we are going to get a q to the power of 2, which is 1 over 2. That means we will get 1 over 4, which is 0.25, is not less than 0.1. When we're going to try q to the power of 3, it is 1 over 2, which is the power of 3, which is 1 over 8, which is also not less than zero point 0.1. And if we're going to get a q to the power of 4, that will give me 1 over 2 to the power of 4, which is 1 over 16, which is also, no, this one is less than zero point 0.1. You can check it by your calculator even to deal with these fractions or make a long division. So you found now 4. 4 can be the least or the smallest integer number for n which can satisfy this relation. So you can say that, therefore, you must toss a coin at least 4 times to make the probability of getting at least 4 times. This means 4, 5, or whatever. And to make the probability of getting ahead at least once greater than zero point 0.9. So the answer should be n is equals to 4 or bigger or more, like 5, 6, 7. So this is the answer. So now we are done with our lesson, and we can say that if you have any question, please don't hesitate to write your comment or your questions, and please don't forget to do subscribe and like and share. Thank you very much for listening, and goodbye.